said, please, please see somebody for me. Ah, you see my baby. Tell her she's alright. She's alright with me. Mr. Narek Ross Patterson.
Okay, now we should be good. Alright, we're back. Alright, let's look at some of the examples first. Alright, so what we did is we know we need to have a login algorithm no matter what. So we need to have an O of n in terms of what can be the problem. So as you can see, well, 30 and 12. So the latest number is 5. Why? Okay, so what we're gonna do is we're gonna first, we know that the GCD is supposed to be 0, right? Let me just open TL draw again. I'm hoping it opens on the same page. Yes, it does. Of course it does. And I like TL draw for this reason. Alright, so what do we have? We have an x comma b is equal to 1. So let's go ahead and check that. So we know if we know a is equal to 30, b is equal to 10. Alright, what is the GCD? No, 12. Sorry, the b is equal to 12. My bad. Okay, so what is the GCD right now? Okay, 30 and 12. So we know 2, 1 to 2, 5 are 10, 2, 6 are 12, 5. So, and I do not know how to take a GCD. What is wrong with me? So GCD of a comma b will be such that 30 is bigger, so it will have to be swapped. So let's say 12 comma 30. Okay, so we know 12 modulus. So this will be 30. So we know 30, 30, and 12 to the 24, 12 to the 36, 12 to the 24, so 24, 24, then we'll have 6 here. And then this goes over here, and we put 12. 12 is done, 12 to 6, 12, 12, and we got 0. Alright, so the GCD is 6. How do you find GCD again? Crap, did I forget how to do GCD? I think I did. I think the GCD... Huh. Okay, we have to find the lowest divisor of A and do it such that, so we cannot do an O of n algorithm. So how do we do this? A, right? Okay, what was GCD? I forgot what was GCD. Greatest common denominator. Greatest common denominator should be 6, right? What is the GCD of A and B? So it doesn't matter. Okay, we know 5. Okay, so we know the GCD of 5 and 12 is equal to 1. So we can do 12. We can do 5 and we can do 12. Right? So 5 to the 10. Then we got 2. 2 and you know 5 comes here. 5, 2, 2 are 4, and 1. So the GCD of these two numbers is 0? Yeah, that's an... Huh. Okay, maybe I got the GCD. What do we do next? Alright, so we need to go ahead. We're going to get greatest common denominator. Now, what do we do next? We did the long division. It's over. And what is next? So, how do we find all the divisors? We don't need to find the all divisor. We need to find the closest divisor, right? Do we need to use Little Finger's theorem? here? I don't think so. Okay, let's just, what's the brute force? How do we find all the divisors? So to find all the divisors. Wow, I have really forgotten most of my problems. I'll have to do Sieve prime for that. Right? Like if I have to do SFP, that'll be a O of n square algorithm. And then get the smallest divisor, right?
Just another day. Just another night alone without you.
Yeah, I'll have to do a Sieve prime then. If I have to find print all divisors, I have to do a, or we can do a login algorithm as well, but we can also do a Sieve prime. So, okay, we can do that, but how will we find all the divisors? So, okay, so we can do an SFP, but will that actually help? SFP is O of n by 3, then GCD is 1, so I think we should be fine. GCD is log n, so this will be the highest. O of, what is the complexity of Sieve prime? Prime algorithm time complexity. It's an O of n time complexity. I have O of n, that means I have to do it only till A. A though.
I'm gonna turn myself around. I'm gonna head back home.
Yeah, A is also 10 to the power of 9, so that's not a good idea. I think, you know what, let's do it this way. Let's try the Sieve of primes. Okay, we'll do a Sieve of primes where we will go ahead and create an SPF int of size A. Alright, then in that size A we will run the algorithm of for whatever I is equal to 0, whatever we add A to like each of the elements. Okay, and then we do a Sieve of prime where for I is equal to Z2, I is less than n, oh sorry, A, I plus plus if SFP of I is equal to I, then SFP of then for int I j is equal to 0, j is whatever, we know how to do this, j plus whatever I, so we start from I into I and j. Okay, so we've got Sieve of primes. Okay, once we get the Sieve, we get the prime Sieve. Holy shit, this will be an algorithm difficult to explain. Okay, then we have to go from right to, so while n is greater than 1, n is not equal to 1, and then go in, we give an int divisor and then DEV. So for each divisor we have to go ahead and check if the GCD is equal to 1 and then return that. Holy crap, I'll have to do all of that. Alright, we're doing that, I guess. Okay, so we're gonna first create an int SFP of size A. Then what we're gonna do is for int I is equal to 2, oh sorry, int I is equal to 0, I is less than A, less than equal to A. So we have to do A plus, and let's do an A plus 2 here. Let's give ourselves a little bit of buffer. A plus 2, I plus plus, so SFP SFP of I is equal to I. Cool. So then we go for int I is equal to 0, I is less than a equal to a, I plus plus, if SFP of I, oops, we have to start from 2, that's why here, SFP is I is equal to I, then we go for int, this is an algorithm and a half, holy shit, into j, do I need to do all of this? We will check, j is equal to I into I, j is less than or equal to a, j plus equals I. I love this algorithm. If SFP of G is equal to J, SFP of J is equal to I. I hate this algorithm so much. Oh god, it's so nasty looking. But it creates like an easy way to kind of get all the devices. But this will still take O of n. So I think getting the divisors the normal way would be better. This is like if you have to find like 100 different devices, right? And then you have to keep on checking and checking and checking and checking. Just another day. So this would be a good idea for that. Okay, fine, we'll come back to this. Okay, we'll come back to see what params, whatever. We know this algorithm, it works. If j is equal to I, j is less than equal to a, we should do j plus equals I. Yeah, it seems reasonable because it will go 2, so it'll find, hey, 2 is equal to 2, so let's convert everything that is 2, then it goes 2 to the 4, 4, 5, 6, and then go to 6, and change it to 2, 6, and 7, whatever. It will just basically make it the lowest possible number. So 4, now how do we find all the devices? So what we're gonna do is, while we are here, you know what, let's write a GCD helper function, okay, int underscore GCD of int n comma m where if n is greater than m, what we will do is n comma m, okay, if m is equal to 0, return 0, right? Return. Do I not remember? I don't remember this algorithm. Shit. How do I not remember? So m, yeah, n is equal to return m. Okay, fine. I should have seen more. If n is less than m, swap. If m, okay, good lord. Let's just make this algorithm right now. Fucking. What are we supposed to say? We have got an n, 10, m, 20. Okay, so we know that the bigger number is always supposed to be inside. Okay, and this will be, and we have to go ahead and get the n modulus of m, right? So the modulus will give us n divided by m. So what do we need to make sure? Okay, so the first thing we need to make sure that on the right hand side we have the smaller number. Alright, so on the right hand side is, so n is less than m. So left hand side, so we have to make sure the right hand side is the smaller number if n is greater than m. Okay, now what do we do? If n is equal to, so that means if m is equal to 0, so what is 0? So when the left hand side number is 0, return m. So when n is equal to 0, return m, I believe, and or else return underscore gcd of n modulus m comma fuck me, you know what, I'll have to remember this someday. I just need to. Okay, let's just compare notes. Let's compare notes. Okay, let's compare notes. Okay, n m m n, I don't know why I did that. If n is less than m, swap n and m. Good. If n is equal to 0, that means over here it should be m is equal to 0, return n, and then n modulus of m comma m. Alright, now what does this do? Okay, just gonna bring this here. So if we have n number 10 comma 20, okay, so what I realized is it'll turn it to 20 comma 10 and then give you n modulus of m. So 10 divided by 20, which is equal to 2, is equal to 0 and 10. 20 is equal to 0 and then return 0 will return n. So the answer will be n? What am I doing? So yeah, it'll go ahead and take m. M over here is, yeah, try 10. So 10. So for somebody it'll go like, hey, if m over here is 10, go back here. So 0 comma 10. We know m is not 10. 0. Oh no, it'll just realize that. Sorry, never mind. So what it'll do is, if it's 0 comma 10, so we're sending 0 comma 10, and 0 comma 10 we know as 0 is less than, swap, so it'll become 10 comma 0. It'll realize, hey, so return 10, so it returns 10 over here. Alright, so the GCD will be 10. Okay, I guess that's one thing. Fine, let's just find all the devices now. I just genuinely don't care. Now we have to find all the divisors of A. Okay. So how do we find? So for each divisor of A, right? Fifteen has 5. Okay. This is taking much longer than I like. So how do we find all the devices? Where is dear broadband? To find all the devices, we have to literally go while b is not equal to 0, int not equal to 0 and did I do and? Divisor modulus b is equal to 0. Let's go. GCD of if GCD of
Sure to let you know. What in the world? What in the world am I gonna do?
okay, what am I doing here? Holy shit, this is a question and a half. Okay, so while b is not equal to 0, I'm saying here there's a divisor b, which is going to be one of the smallest divisor possible. The smallest divisor here is my biggest issue. The smallest divisor is the biggest issue for me, because that means I have to calculate. So SPF here is not a good idea, but what it'll do is it'll at least give me a test case scenario. But what happened? Oh. Are you serious? There was an option to... What? Oh. Okay, so we should be good now, right? Did I just do Ulta? Yeah, I should have like just changed the... Yeah, okay. So I think this is not a good option. Wait, why did it take exceeded time limit from this?
I went down to the river.
I think GCD is wrong.
Sit there all night long.
How is GCD wrong?
Wondering about my life. Wondering what went wrong. Blues in my bottle. Sorrow in my cup.
How is GCD wrong? We checked it.
Well, I've been down for so long. It's getting hard to get better.
Okay, so this is the compilation error, so we're still good. Where are we going? Time limit exceeded though.
It's hard to find
That makes no
one.
sense.
Even harder to find a friend. When
Alright,
think
fuck
love's
me.
beginning, it turns out to be the end. Blues in my bottle.
Divisor modulus b is equal to 0 if gcd.f is equal to 1, return def or else def.
Sorrow in my cup.
I forgot to I forgot to do b is equal to I think that's what it b by divisor I think.
They say the Tin Pan Alley.
What am I missing? Divisor is equal to SPF of B.
They got cutting and shooting.
No, B is not equal to 1.
Soon
Shoot.
as the sun goes down, oh, tell me. What kind of place can the alley be?
Divisor SPF of B, divisor div def if divisor comma a is equal to 1, return divisor.
For every woman I get,
Or else B
Lord,
by
the
divisor.
alley takes away from me.
B is equal to B by divisor. So what is happening here? So this has to be the place. So 12. SPF of 12. So let's go back to TL draw. Sorry about that. So we know SPF of 12 is equal to 2. Okay. So while B is not equal to 1 and B more and divisor modulus 2 modulus 0 is equal to 0. What is it doing? So it should just check the GCD of 12 comma whatever, doesn't matter. Oh, divisors of A, right? What am I doing? Jesus, X and B are co-primes. So while A modulus divisor, fuck me. Oh, for fuck's sake. Jesus Christ, why am I so stupid? If the time complexity is correct on this one, I will roll. What?
But you can't be found.
Uh,
Saw her early in the morning.
okay.
She was Tin Pan Alley bound.
That's not a time complexity issue. The expected return value was 90. We got 2.
What kind of place can the alley be?
Why? Oh, you wanna even do it itself?
For every woman I get,
Why don't I do A? Okay. Does it still work? Because we're still reducing it. It's cool. Yes, it's cool. Why am I like this? Why am I like this? Okay, that's bullshit. That's bullshit. Because see, if A is equal to 90, B is equal to 47. Alright? Your function returned 2. Okay? Does 90 and 47 if the GCD. Oh. Return A. I'm gonna kill myself one day. Yeah, okay, we got a daily goal of 6 added. We're good, we're good. Okay, so what are we missing here? Okay. So, we're going through each divisor of A, right? So we're going through A, we will go A by 2, then A by 2 again, whatever. So we have, what is the test case here? What is the test case that is failing? We don't need that though, but whatever. So we have, well, the test case is 21, 49. Your function returned 1 rather than 3. Huh. Let's see what the issue is. So we know A is 21, B is 49. A is 21, B is 49. If I'm right, yes you are. Okay, so what are we doing here? So for 21 and 49, this is the main loop. We know 21 will be 3, the minimum. Yeah, 3 7 21. Yeah, 3 7 21. So 3 is the minimum that it will divide by. And so what did we do? We took, yeah, that's crazy, right? Because see, we did SPF of 21 is oh, that's not a divisor. Okay, I have to do both.
there is nothing I can do. If you leave me here to cry,
No, right? Because it should come as a
there is
divisor, right?
nothing I can do.
So
If you leave
21.
me here to cry,
Oh, divisors have 3 properties, right? The number of divisors
you
can
know
be
my
based if they're full prime,
love
half
will
prime, and other
follow
prime.
you
Okay, so we need to go ahead and look at the 3 conditions of
as
the divisors, right? So
go passing by.
if, what do you call this? If it's a prime
I give you
if it's a
all I
non-prime,
own.
and whatever. Okay, so we can look into count divisors,
That's
right?
one thing you can't deny.
I think we should be able to look into count divisors. I think these are the only 2 cases
I
that
give
should
you
be.
all I own.
Nope.
Yeah,
Okay.
that's one thing.
14. 14 gram. A is 42, 33. B is 33. Okay. 42. 42 will have lowest 2. 2 2s are 4. 2 6 are 12. does not work. Again, we have to get 14 somehow. 2 does not work. 26 does not work. 2. 2 to 3 is 6. How do you get 14? 2 is 4. So 4 is 1. And then 13. Wait, what? What are all the divisors for 42? 42 is 2. 2s are 4. 2 1s are 2. 3. So the 21. 7. 1 is 7. Okay, 42 is sorry. 7 2s are 14. So 7 2s are 14. So 14 is one of the divisors that wants me to take into consideration. Okay. So this is not the best algorithm for it. I think over here I should get some help, because the biggest problem over here is I'm not taking all the divisors, I'm taking the lowest common divisor. So if I did with the login algorithm for I into I, where I started with I is equal to n and then minus minus, while like, so basically the usual system is I is equal to 2, I is less than equal to I into I is less than equal to n, and then we do I plus plus. So what if we do I is equal to n minus 1,
I'm gonna leave it up to you.
and then go from right to left. So n minus 1, so it'll be whatever. So I is equal to n, and then we did something like that. We could do a reverse way. I can ask for
I'm
help.
gonna leave it up to you. I'll say so long, but now goodbye. You know my love will follow you.
But this should also help. Let's see how C prime will help. Okay. So I got 42. Okay. 2. 2s are 4. 2 1s are 2. 2. 3. 7 are 21. 7. Okay, 7. So it's gonna go 2, 3, and 7. So this is how the greatest kind of goes, right? Now, A will always be greater, but we have to do an else. If A itself, because A will always be greater than the whatever thing, so we need to go ahead and just return A in that case, or else we have to find the greatest number that will be in the end. Good lord.
Birds flying high.
I'm so stupid.
How I feel. Sun in
the sky. You know how I feel. Breeze drifting on by. You know how I feel. It's a new dawn. It's a new day. It's a new life for me. And I'm
This is such a bad trip, man. This is such a bad trip.
feeling
I swear to God, this is such a bad trip. I don't even know anymore. You know what?
stars when you shine, well, you know how I feel. Scent of the pine, you know how I
Expected 3
feel.
function turns
Oh,
on. Why?
freedom is mine, and I know
Why
how
would
I
it do that?
feel. It's a new dawn, it's a
A
new
by divisor is equal to
day,
equal
it's
to
a
1,
new
and the GCD of
life.
divisor,
Said it's a
comma
new
B is
dawn,
equal to 1, then
it's a
return
new
the fucking divisor.
life.
Why would you do that?
And I'm
Oh my god, I'm so weirded out right now. This should have worked. This should have worked. I'm struggling. Why am I struggling? Okay, you know what? Let's go get some help. Let's get some help. Let's have a TA give us a good thrashing. Alright? Okay, so I'm really hiding because the point is I don't want you to see the guy's name. I'm gonna stop the music a bit because it would have been a shit show. Ah, this is insanity. This is absolute insanity. Hmm. I'm doing well. I don't know why I was like so underconfident for the second. I mean, I know I still needed help, but um, yeah, it's fuck. Fine. Do 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 do. Yeah, I think I can still hear him. Let's see. Because I want to give him like 100% tension. I'm not gonna goddamn do shit. Record this session. This is crazy though. I took a lot of help for this, and I'm still like getting the wrong answer. So 21 and 49 it's failing for. Wow, this guy is taking a bit of time. Okay, till then we'll figure out what we did wrong. So let's assume that GCD is correct. So what we have got a divisor of GCD of A comma B is equal to 1, then divisor by 1 is equal to GCD of so and so. Uh, so what does it check? So for say, so we're failing for 42 and stupid. 21 and 49. So we are failing for 21 and 49. Okay, 21 and 49. So what are the divisor for 21? 21 is 3. Are you joking? Hey Yash, can you hear me?
Hello?
Hey Yash, can you hear me?
Yes, yes, I can hear you.
All right, so I am failing for a test case for 29 and 41. I'm going to first share my screen and then I'll tell you what my thought process was. Is that fine?
Yes,
All right.
yes.
So my thought process was as simplistic as possible. I decided to use a Ceph prime algorithm.
Okay.
Yeah, I was a bit worried because 10 to the power of 9 is the maximum. I thought I might get a.
Actually, can you speak up? Your voice is low.
Oh, is it still low?
No, 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 no.
Is it still low? Is it better?
No, no, that's fine. Now fine. Now it's fine.
Is it using the wrong mic? Okay, I'll just check the mic later. I think it's using the wrong mic or something. But yeah, okay. I'm hoping
Yes.
I'm hoping I'm a much clearer.
Yes, yes.
One second. I just want to confirm. I'm so sorry. I'm just gonna confirm Oh, I cannot change the settings here.
Okay, okay, okay.
One second. Just give me a second. Yeah. How about now? Is this better?
Now that's fine. That's fine.
Ah, perfect. Okay, yeah, I was using the wrong mic. So first I decided to simply this is the GCD algorithm.
Okay.
So I'm supposed to get the largest coprime for a divisor.
Okay.
Alright.
So let me see the question. You are given two positive number A and B. You need to find the maximum value integer x such that x divides A. Okay.
Mm-hmm.
Okay. X and B are co-prime. That is GCD of X and B is 1. Okay, okay.
Alright. So simple things. I first implemented the GCD algorithm. That's in the topic.
Yes, that is the first step.
Okay, second thing, I decided to use C prime, created a C prime on A plus 2 just to be sure.
Okay.
I know it's A plus 1 is fine, but yeah. Okay, so then I went through getting each of the divisors using if while A is not equal to 1, divisor is equal to SPFF. Just like ignore this, I was testing something.
Yes, yes.
While A is not equal to 0 and the divisor is not equal to 0, check if the GCD of A and B is equal to 1. So
1 or not. Yes.
yes, and or then return A. If A by B is equal to 1 and the GCD of the divisor and B is equal to 1, return the divisor. Does that make sense?
GCD of divisor A and B equal to 1. Okay. Divisor is A by B equal to 1 and GCD of these both are equal to 1. Then you are returning the divisor and then
Yes.
you are equal to A by divisor you are doing. Okay.
Yes. Does that make sense?
Okay. Okay. Line number 49. What are they going to where you're
Yeah,
using it?
I again just ignore this. I was testing something else in my
Okay,
head.
okay, okay. Okay.
Does not require. I'm sorry. I'm just going to delete it. You're
Okay,
right.
no problem.
Okay. All right. So what do I do now? So here is the question. So spelling for 29 and 49, the expected return is 3 and 1, which I do not understand why it failed because let me just show you 21, 49. All right. So the divisors for 21, 21 is A, 49
Yes.
is B, right? If I'm
Okay.
right, 3 GCD of 3 and 49 is equal to 1.
Okay.
All right. Because that's the answer. That's the expected answer. So I'm guessing again GCD of
GCD, okay. So divisor SPF A C prime, okay, while A not equal to 1.
mhm.
All right. So here divisor will be what? SPF A is
Uh,
uh,
so 3, right? 21. So if you're taking 21, SPF of 21 will be 3. Okay, should I show you my C prime algorithm maybe first?
yes, yes.
Okay, because that can be wrong, right? All right, the C prime algorithm. First, I just took a simple loop till A, SPF of I is equal to I.
Okay.
Started from 2 less than equal to A, I plus plus. If SPF of I is equal to I, then go into the J loop, which will start I into I. If J is less than equal to A, J plus I. Does that make sense? Because,
Okay, okay, got
okay,
it.
if SPF of J is equal to J, then SPF of J is equal to I.
Okay,
Cool?
okay. So for 21, it's 3.
Yep.
Okay. And A is 21 right now, right?
Yes, A is 21.
Okay. Let's see divisor equal to 3. Then divisor equal to 3 and B is 49.
Yes.
Let me just do it on pen and paper. 21 and 49. Okay.
Mm-hmm.
Now your A not equal to 1 and A modular divisor equal to 0. That is fine. It's not equal to 1.
Mm-hmm.
So you are going inside that while loop. GCD of A and B is 1. So 21 GCD of 21 and 49. No, it's not equal to 1. Okay. So divisor is 3 here.
Mm-hmm.
So A by 3, A by divisor equal to 1.
No, that's what I do not know what to write, what condition to write here that it because if I do just this, it might
Okay.
give the smaller numbers and it would not give 7. So like if the 7 is like the last number that is multiplied, like does that make sense?
Okay. So I don't think that condition is an A by divisor equal to 1.
Yeah. That's the wrong condition. So that's what I wanted to kind of fix over here.
Okay. So GCD of divisor B, okay, divisor and B equal to 1. If it is equal to 1, then you are returning the divisor,
Hmm.
right? Else A equal to divisor. No, no, no. Let me just.
Hmm.
If it is divisor, then A equal to A by divisor or A equal to divisor you should write. Wait.
A is equal to A by divisor, right? Because we have to move forward towards the things. So it'll be like
Okay.
21 by 3 so that we can get.
Okay, can you run it now? Because that condition we have removed.
No, it'll fail for 47, I think. 42.
Okay,
So 42, it'll fail because the answer is expected to be 7, I guess.
okay.
No, 14. So oh yeah, um, uh, it's 2 into 7 into 2.
Yes.
So 7 into 2. So it'll fail for 7 into 2.
Okay. Okay, can you give me 1 minute time?
No, no,
Just
don't worry, don't worry. Take your time.
yes. GCD SP equal to 1. Okay, one simpler thing you can do it.
Mm-hmm.
This much is not required.
Okay.
First, you will check that if GCD of AB is not equal to 1. Okay.
Mm-hmm.
I mean, you will run a while loop
Mm-hmm.
till you got GCD equal to 1. For example, if it is 21 and 49, right?
Mm-hmm.
So if what is GCD? GCD is 7.
Mm-hmm.
GCD is 7, right? So it's not equal to 1. Then you will do what? A equal to 21. So you will do 21 by 7. A equal to 21 by 7.
Okay.
So now A is 3. Okay. Now you will see the GCD of 3 and 49.
Okay.
GCD of 3. It's equal to 1.
Yeah.
So you will return A directly. And right now A is changed to 3.
So what do you want me to change exactly? Can you give me an example? Like
Yes, you don't need that,
full while
calculate
loop?
that FPF. Yes.
Okay,
So,
I don't need to calculate the FPS as
yes,
that.
yes.
So how do you
You
do it?
can directly do it in while loop.
Okay, navigate me. I think that'll be required. Okay, I'm gonna delete that later. So let's just do this while loop.
Yes, you can just comment it.
This while loop? No, no,
All
no.
thing,
Yeah,
all
yeah,
the code,
got
all
it.
the code. Yes, just comment
I'm
it.
gonna keep the GCD then.
Yeah,
Just gonna.
GCD you have to keep.
Yeah.
GCD is necessary.
Okay.
Yes. Now run a while loop
Mm-hmm.
while GCD of A and B not equal to 1.
Okay.
While GCD of A and B. I think you are not using your function, you are using inbuilt function of GCD.
No, 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 no. This C.
Okay. That GCD inbuilt function also looks like
Oh,
this.
really? I thought the inbuilt bar function does not look like this. That's why I'm using it this one.
Okay. If you will remove your that GCD function, then also it will work. Okay. But don't
Should
remove
I
that.
should I just replace this? Maybe we can just change all
Just
occurrences
replace
to.
that underscore. Just only that GCD.
Okay, we can just do
Yes.
this. I'm pretty sure this should be fine. Okay.
Yes. Not equal to 1. Because if it is not equal to 1, you have to traverse. Okay.
Yep.
So A equal to
Mm-hmm.
A by
Mm-hmm.
GCD A and B. Yes.
Okay.
And at last in line number 38, return A.
Okay.
That's fine.
Are you serious?
Yes.
No, there is no way. Okay, you have to explain the math to me. Okay, I'm gonna let's do a trial run. Okay, can you give me two numbers?
Yes. Let's take an example.
Okay.
49 and 21. Because A moduli x equal to 0, you have to find. So x will be from 1 to A, right?
Okay.
X will be from 1
One,
to
two.
A.
Yeah, that's the first thing I literally I think I wrote. No, I thought x will be equal to 1 to b, right?
Uh, No, no. First condition. Just see the first condition. X. Okay.
Yeah.
For a moduli x equal to 0,
Mm-hmm.
x will be in 1 to a.
Yeah, that I knew.
Yes.
But if they have to be oh right, co-prime can be anywhere. Yeah, one to a.
Yes. 1 to a.
Mm-hmm.
The second condition is GCD of x and b should be 1.
Yep.
Right. So we will start from a and
Mm-hmm.
we will keep on checking the factors of a. Right.
Yep.
Okay. So from a is the factor of itself.
Yep.
So we will take x as a initially.
Okay. Right.
Now we have to check that if GCD of x and b
Mm-hmm.
is equal to 1 or not.
Okay.
If it is equal to 1, we will return that x.
Yeah, I understood that. I understood that point.
Yes.
So why did we get GCD by A? That's my main question.
Okay, a by GCD.
Yeah, sorry, A by GCD.
Yes, I am explaining. So now
Mm-hmm.
a, what is the GCD of a and b? We got it 7. Okay. In this
Okay.
case, if it is 21 and 49.
Okay.
So you can see that a equal to a by GCD. So one factor is 7.
Okay. Yep.
One factor of a is 7.
Yep.
Okay.
Mm-hmm.
We have to remove this 7 from a. That is
Okay.
divided.
So A over
Okay.
here is again 21, right?
Yes.
So 21 by
Because 7 is creating the problem here.
okay, yep, 3. Got it.
Yes. Now we
Oh,
will check on 3.
okay. Okay.
And if 3 GCD of 3 and B is not 1,
Mm-hmm.
then we will remove 3 from A again.
Okay, got it.
Got it?
And then the answer itself would become B, right?
Yes.
Because the GCD of 1 and B is
Yes,
B.
we are changing the A in the while loop. Okay.
Yes.
Just understand that A is X.
Yes. I knew that we had to go with some way like that, but okay, I get it now. I get it.
Okay.
All right. This makes a lot of sense. Thank you. Thanks a lot.
Yes.
I am absolutely irritated that it's a three-line code. I am I am very angry with that. Oh God. I think I will
Yeah.
remember this.
Yes, yes. Something like.
Chalo, thanks a lot. Thanks a lot, Yash. I really appreciate your
Okay,
time.
thank you.
Thank you. Bye-bye.
Bye.
I I was stuck here for 45 minutes for 3 lines of code. I had to delete all of this. Okay, this is fine. This one I had to write. Okay, it's not 3 lines per se, but still, I got so bamboozled. I got so bamboozled. Alright, with that, I'm gonna end this stream. But this is, see, this is why we cannot have nice things. Oh god. Oh god.